What's the largest star in the universe? If you Google it right now, you'll get the wrong answer. And scientists, they've been arguing about this for over a decade. By the end of this video, you'll know the real answer. And trust me, it's way more interesting than you think. Here's what we're covering today. First, we'll expose the star that held the crown for years, until astronomers realized they measured it wrong. Then, we'll meet the new champion, a monster so big it shouldn't exist. And finally, I'll show you why finding the largest star is one of the hardest problems in astronomy. Because out there, nothing is what it seems. Cosmonauts, if you've ever wondered just how massive stars can get, stick around. For years, if you asked any astronomer what the biggest star was, they'd give you one answer: UY Scuti. This red supergiant sits about 9,500 light-years away in the constellation Scutum. And the numbers? Absolutely insane. In 2012, astronomers, using the Very Large Telescope in Chile, measured UY Scuti at 1,708 times the radius of our Sun. Let me put that in perspective. If you dropped UY Scuti where our Sun is right now, its surface would swallow Mercury, Venus, Earth, Mars, and it wouldn't stop until it reached Jupiter's orbit. That's a star so wide, if you drove around it at highway speed, 70 miles per hour, it would take you over 6,500 years to complete one lap. Your descendants, hundreds of generations from now, still wouldn't have finished the drive. Even light, the fastest thing in the universe, takes nearly 7 hours just to circle this thing once. Our Sun? 14 seconds. So UY Scuti reigned supreme. Case closed, right? Not so fast, because recently astronomers made a discovery that knocked UY Scuti off its throne. Meet Stephenson 218. This star is so remote, so buried in cosmic dust, that we didn't even get a clear look at it until 2007. It sits about 19,000 light-years away, near a cluster of red supergiants at the base of one of the Milky Way's spiral arms. And the size? Stephenson 218 clocks in at an estimated 2,150 times the radius of our Sun. If you placed Stephenson 218 at the center of our solar system, it wouldn't just eat Jupiter's orbit, it would extend past Saturn. You could fit 10 billion suns inside this thing and still have room left over. Flying around it at the speed of light, almost 9 hours. So we found the biggest star, right? Crown it and move on? Well, according to our best physics, Stephenson 218 shouldn't exist. Stellar evolution theory says stars max out around 1,500 solar radii. Beyond that, they become too unstable. Gravity can't hold them together. They should tear themselves apart. So either our measurements are wrong or our physics is incomplete. And honestly, astronomers suspect it's the measurements. Here's why. Measuring the size of a distant star sounds straightforward. It's not. In fact, it might be one of the trickiest problems in astronomy. Stars don't have hard edges. Think about it. When you look at the Sun, you see a glowing disk. But that surface you're seeing? It's called the photosphere. And it's basically just the layer where light can finally escape. Below that, more star. Above that, a fuzzy atmosphere that fades into space. So where does the star actually end? Scientists have to pick a definition, and different methods give different answers. Now add distance to the equation. Stephenson 218 is 19,000 light-years away. That's about 112 quadrillion miles. The uncertainty on that distance is over 50%. We're not even sure how far away this star is, within a margin of half its estimated distance. Why does distance matter so much? Because to calculate a star's size, you need to know how bright it truly is, and brightness depends on distance. If Stephenson 218 is closer than we think, it's actually smaller. If it's farther, it's even bigger. This exact problem just wrecked UY Scuti's record. Using improved distance measurements from the Gaia Space Telescope, along with a 2023 study that used new techniques to analyze red supergiants, astronomers recalculated UY Scuti's numbers. The result? UY Scuti is not 1,708 solar radii. It seems to be closer to 909. That's nearly half the original size. Suddenly, UY Scuti isn't even in the top 10. It's comparable to Betelgeuse, the famous red giant in Orion's shoulder. Still massive, but not the champion. And here's the uncomfortable truth. The same uncertainty applies to Stephenson 218. Its 2,150 solar radii estimate came from a 2012 paper using assumptions about temperature and distance that may not hold up. So if Stephenson 218 might be wrong and UY Scuti already fell, who's actually the biggest? Let me show you the current frontrunners based on the most reliable current measurements. Number 1, WOH G64. This red supergiant lives in the Large Magellanic Cloud, a small galaxy orbiting the Milky Way about 160,000 light-years from Earth. WOH G64 measures approximately 1,540 solar radii, though some estimates push it as high as 2,500. That's right at or beyond the theoretical limit. And because it's in a neighboring galaxy, its distance is actually easier to pin down than stars buried in our own dusty Milky Way. Close contender, Westerlund 126, also known as W26. This star sits in the Westerlund 1 cluster, about 15,000 light-years away. Estimates put its radius between 1,530 and 2,550 solar radii. The uncertainty is massive, but it's definitely in the running for the largest known star. Number 2, VY Canis Majoris. This one's a classic. Astronomers have studied VY Canis Majoris for decades. It sits about 3,900 light-years away and measures around 1,420 solar radii. Here's something wild. This star is actively dying. It's shedding material so fast, it loses the equivalent of 30 Earth masses every single year. Clouds of ejected gas extend billions of miles into space. Number 3, Mu Cephei, also known as Herschel's garnet star because of its deep red color. This beast sits about 2,400 to 2,800 light-years away. Estimates of its radius range from around 970 to 1,650 solar radii, depending on the method used. The uncertainty is huge, but it's definitely one of the largest stars visible to the naked eye. Now here's the thing I want you to understand. This list will change. UY Scuti held the crown until it didn't. WOH G64 might get dethroned next week if a new telescope gives us better data. And Stephenson 218? It could turn out to be 2,150 solar radii after all. Or it could shrink like UY Scuti did. That's the nature of this science. We're measuring objects that are thousands of light-years away, shrouded in cosmic dust, with surfaces that don't really exist in the traditional sense. Every answer comes with an asterisk. So why does any of this matter? These supergiant stars don't just sit there looking impressive. They're cosmic factories. Inside their cores, they forge heavy elements: carbon, oxygen, iron, the stuff that makes up planets, that makes up you. And when they die, they explode as supernovae, some of the most violent events in the universe. Stephenson 218, WOH G64, VY Canis Majoris. All of these giants are on borrowed time. Cosmically speaking, they'll go supernova within the next million years, maybe sooner. When VY Canis Majoris explodes, it might be visible from Earth in broad daylight, even from 3,900 light-years away. And here's the profound part. The fact that we're arguing about which star is biggest is proof of how far we've come. About 100 years ago, we didn't even know other galaxies existed. Now, we're measuring the fuzzy edges of dying stars in neighboring galaxies, 160,000 light-years away. We're not just finding answers. We're learning which questions we don't even know how to ask yet. If stars can push the limits of physics and our measurements keep changing, what else out there have we gotten completely wrong? Drop your guess in the comments. And if you enjoyed this deep dive into stellar giants, smash that subscribe button. We've got more cosmic mysteries coming. Until then, cosmonauts, keep looking up.